I'm Julie Loisel, and I will guide you through our project objectives and progress. This new project looks at peat patches, which have been observed in areas beyond the northern peatland biome limit. These patches, or baby peatlands if you wish, may represent the initial stage of peatland formation under a warming climate. Peatlands function as natural carbon stores. Here's an example here. So this warming-induced increase in below-ground carbon storage in those baby peatlands can be seen, in a way, as the equivalent of above-ground vegetation greening, which you might be familiar with. In this project, we want to find out how widespread these peat patches are in the Arctic, why they are there, and what factors control their formation, distribution, and dynamics. Our main question is here. Will the warming Arctic evolve into a peatland-rich landscape as the boreal zone is now? Or are there some essential conditions missing in a warmer Arctic that will prevent this? Here's a map showing you 3 main locations where our team is collecting soil data. The North Slope of Alaska, shown as number 1, the Canadian High Arctic with Victoria Island and around Cambridge Bay with number 2, and the southern end of Baffin Island and the northern end of Quebec, shown with number 3. To give you a little context, the green area on the map here shows you the current peatland extent and the peatland core sites that already exist in red. So clearly our sites are beyond that northern limit. In this project, there is the core collection I just described. Secondly, there are soil incubations that are underway, some of them from these 3 different sites. There is also a data synthesis component to this project. Here you see a map showing you all the peatland cores that already exist to calculate the recent rate of carbon accumulation. And just so you know, new cores will be sent to us from a number of international collaborators listed on the right. There is a modeling aspect as well. We are using 2 different types of models. One of them is the Holocene peat model, so an ecosystem type of model. And we're also using models that allow us to analyze the landscape scale carbon balance. In this case, we are using LPJ-STM and PTEM.